Why is it important to have a good understanding of the different types of CNC machines? Well, if you're not familiar with the limitations and benefits of each different type of CNC machine, you might not be able to design for it properly. And that's really what ends up costing a lot of time and money. That's why today what we're going to be covering is how the machines work and the limitations and benefits of each different machine type. Hi, my name is Nico and welcome back to another episode in our series, What is CNC Machining? In the last episode, we briefly touched upon the different types of machines, but today we're going to dive into more detail as promised. At the end of the video, you're going to have a clear understanding of the different types of machines and how they work. But before we start, it's important to note that in this video, we'll be covering CNC machines that remove material using cutting tools, as these are the most common machines and have the widest range of applications. This means that laser cutters, plasma cutters, and EDM machines are not covered. Alright, let's get started. CNC machines can be broken up into two main categories or machine types: 3-axis CNC machines and multi-axis CNC machines. 3-axis machines are CNC milling or CNC turning machines, also known as lathes. The multi-axis CNC machines can be index CNC machines, continuous 5-axis CNC machines, and mill turning machines. Let's start with 3-axis CNC machines. CNC milling machines and CNC turning machines allow the movement of the cutting tool relative to the workpiece in 3 linear axes: left-right, back-forth, and up-down. However, it's good to note that lathes sometimes miss one or more of those combinations. 3-axis CNC milling machines are very common because they can produce most standard geometries. Because they're easier to program and operate, they lead to a relatively low machining startup cost. During CNC milling, the workpiece is held stationary directly on the machine bed or in a vise. Material is removed from the workpiece using specialized cutting tools that rotate at a very high speed. The cutting tools are attached to a spindle which can move along the 3 linear axes we just discussed. Usually, several rounds of cutting are required to produce the desired part. First, an approximate geometry is given to the workpiece intended at removing material quickly at a lower accuracy. Then one or more finishing rounds are used to produce the final part. It's good to mention that tool axis can be a design restriction in CNC milling. Because there are 3 axes, certain areas might be impossible to reach. A workpiece can be rotated, so it doesn't have to be a problem, but multiple rotations can increase your machining and labor costs. Just something to bear in mind. Let's move on to CNC turning machines, or as they're commonly referred to as lathes. CNC lathes can produce parts at a much higher rate and at a lower cost per unit than CNC mills. This is especially relevant for larger volumes. During CNC turning, the workpiece is held on the spindle while rotating at a high speed. A cutting tool or center drill traces the outer and inner perimeter of the part, forming the geometry. Holes along the center axes can also be manufactured using center drills and internal cutting tools. Typically, CNC lathes are used to produce parts with a cylindrical profile. This is also the downside. They can only produce that geometry. To overcome this limitation, features of the part are often CNC milled in a separate machining step. Alternatively, 5-axis mill turning CNC centers can be used to produce the same geometry in one step. Now, it's time for multi-axis or 5-axis CNC machining. These machines can rotate on the same 3 linear axes as 3-axis CNC machines. What makes them different is that they can rotate on an additional 2 axes, making 5 axes in total. For example, 5-axis CNC milling machine centers allow rotation on the 3 linear axes of movement, and in addition, they can also rotate the machine bed or the tool head, or both. Because of this, 5-axis CNC machines can handle more complex geometries. However, this does come with an increased cost because it requires specialized machinery and operators with expert knowledge. If you're creating highly complex or topology optimized metal parts, 3D printing is usually a more suitable option. Let's talk about indexed 5-axis CNC machines and how they work. During machining, the cutting tool can only move along 3 linear axes. However, between operations, the bed and the tool head can rotate automatically, giving access to the workpiece from a different angle. Because of this, no human intervention is required to manually reposition the workpiece. Parts with more complex geometries can therefore be manufactured faster and at a higher accuracy than in a 3-axis CNC mill. But they lack the true free-form capabilities of a continuous 5-axis CNC machine. Continuous 5-axis CNC milling machines have a very similar architecture to indexed 5-axis CNC milling machines. However, there is one big difference. Continuous 5-axis CNC milling machines allow for the movement of all 5 axes at the same time during all machining operations. But these advanced capabilities come at a high cost. With continuous 5-axis CNC milling, you need expensive machines and highly trained machinists to accurately program the machines. Finally, we have mill-turning CNC centers. Mill-turning CNC centers are exactly like CNC turning machines, only they are also equipped with CNC milling tools. The workpiece is attached to a spindle that can either rotate at high speeds, like a lathe, or position it at a precise angle, like a 5-axis CNC mill. Lathe and milling cutting tools are used to remove material from the workpiece, forming the part. A variation of the mill-turning center is the Swiss-style lathe, which typically has a higher precision. Mill-turning systems take advantage of both the high productivity of CNC turning systems and the geometric flexibility of CNC milling systems. Alright, we covered most of the CNC machines that use cutting tools. Let's look at the most important things that we learned. 3-axis CNC milling machines manufacture parts with relatively simple geometries with excellent accuracy and at a low cost. CNC lathes have the lowest cost per unit but are only suitable for part geometries with rotational symmetry. Indexed 5-axis CNC milling machines manufacture parts with features that do not align with one of the main axes quickly and with very high accuracy. Continuous 5-axis CNC milling machines manufacture parts with highly complex, organic geometries and smooth contours, but at a high cost. Mill-turning CNC centers combine the benefits of CNC turning and CNC milling into a single system to manufacture complex parts at a lower cost than other 5-axis CNC systems. That's all for this episode on the different types of CNC machines. I hope everything was clear and that you learned something new. Any questions? Please drop them in the comments below and we're happy to get back to you. Also, if you found this content interesting, give us a thumbs up and subscribe for future episodes. Next week, Design for Manufacturing.